I am N. Kodesh. My roll number is 2195180475, branch ECE, section B. Today my topic about on Ruby laser. Overview, introduction, historical importance, construction, working, application, drawbacks. Introduction. A Ruby laser is a solid-state laser that uses a synthetic Ruby crystal as its gain medium. It was the first type of laser invented and was first operated by Theodore H. Ted Meinman at August Research Laboratory in 1960. The Ruby mineral corundum is aluminum oxide with a small amount, about 0.05% of chromium, which gives it its characteristic pink or red color by absorbing green and blue light. The Ruby laser is used as a pulsar laser, producing red light at 694.3 nanometers. After receiving a pumping flash from the flash tube, the laser light emerges out from a long as the excited atom persists in the ruby rod, which is typically about a millisecond. Historical importance. A pulsar ruby laser was used for the famous laser ranging experiment, which was connected with a corner reflector placed on the moon by Apollo astronauts. This determined the distance to the moon with the accuracy of about 15 centimeters, a 3-level solid-state laser. In this diagram, you can see a partially reflecting surface at one end and a fully reflected surface at the other end, which is light is emitted only partially reflected surface. Laser construction. The active laser medium, laser gain and amplification medium, is a synthetic ruby rod. Ruby is an aluminum oxide crystal in which some of the aluminum atoms have been replaced with chromium atoms. 0.05% weight. Chromium gives ruby its characteristic red color and is responsible for the lasing behavior of the crystal. Chromium atoms absorb green and blue light and emit or reflect only red light. For a ruby laser, a crystal of ruby is formed into a cylinder. The rod's ends had to be polished with great precision, such that the ends of the rod were flat to within a quarter of a wavelength of the output light and parallel to each other within a few seconds of work. The finely polished ends of the rod were silvered, one end completely, and other is partially, the other only partially. The rod with its reflective ends then act as a Fabry Perot etalon or a gyrus turnois etalon. A xenon lamp is rolled over ruby rod and is used for pumping ions to excited state. Working of ruby laser. Ruby laser is based on three energy levels. Three energy levels. We know that the upper energy level is E3, short-lived period. E1 is ground state. E2 is a metastable state with a lifetime 0.003 seconds. We can see in this diagram the ground state. When a photon is incident, it goes energy level 3 and comes to the after completion of lifetime, it comes to the metastable state. After completion of lifetime 0.003 seconds, it comes to the ground state, emitting a photons. When a flashlight falls on ruby rod, radiations of wavelength 5500 angstrom are absorbed by chromium plus 3 ions, which are pumped to E3. You can see the diagram absorption bands of the chromium 3 ions, green light absorbed, blue light absorbed. The ions, after giving a part of their energy to crystal lattice, decay to E2 state undergoing radiation-less transition. You can see in this diagram blue light absorbed, green light absorbed. Absorption bands of the EV chromium 3 plus ions energy level state 3 goes to metastable state. The photons are emitted. In metastable state, the concentration of the ions increases while that of E1 decreases. Hence, population inversion is achieved. Non-radiative transition to the metastable state from the pumped levels. Ion at energy level 2 level initiates the stimulation emission by other chromium 3 plus ions in metastable state. We can see in this diagram absorption bands of the chromium plus 3 ions, green light absorbed, green light and blue light absorbed in metastable state comes to the down After completion of lifetime 0.003 lifetime comes to the ground state E1 energy level 1. A photon is emitted. It continues simultaneously. Laser output is in extreme red at 694.3 nanometers at 1.79 eV. Application: Ruby lasers have declined in use with the discovery of better laser lasing medium. They are still used in a number of applications where short passes of red light are required. Holographers around the world produce holographic prototypes with Ruby lasers in sizes up to a meter squared. Many non-destructive testing labs use Ruby lasers to create holograms of large objects such as aircraft tires to look for weakness in the lining. Ruby lasers were used extensively in tattoo and hair removal. Drawbacks of Ruby laser. The laser requires high pumping power because the laser transition terminates at the ground state, and more than half of a ground state atoms must be pumped to higher state to achieve population inversion. The efficiency of Ruby laser is very low because only green component of the pumping light is used while the rest of components are left unused. The laser output is not continuous but occurs in the form of pulses of microseconds duration. The defects due to crystalline imperfection are also present in the laser. Conclusion: a ruby laser is a solid state laser that uses a synthetic ruby crystal as its gain medium. We know that. Many non destructive testing labs are use ruby lasers to create holograms of large objects such as aircrafts, tires to look for weakness in the lining. It is used to find distance between planets. In some work, many were uses in ruby lasers. Thank you.